G'day, Chris here and welcome back to ClickSpring. For the sort of work that many of us do in the home shop, a small lathe like this is pretty much indispensable. The working envelope is often a bit limiting, but for small components, its light feel makes it well suited to the job. And maybe most helpfully of all, it's an affordable way to get started in machining. This particular model of lathe, a Sherline, is one of the more customisable small lathes on the market. And the company offer a large range of additional fixtures, fittings and add-ons to extend the capacity of their machines. But there is one addition that I need for future projects that they don't currently offer, and that's a Watchmakers style faceplate. Now, to be fair, this machine isn't marketed as a Watchmaker's lathe, so that's not surprising. And they do offer a general engineering style of faceplate that'll do the job in many cases. But the requirements for watchmaking are fairly specific, and so a dedicated tool with some particular features is called for, because there are many watch components that are not the typical cylindrical turned part, but tend to instead be more flat, with precisely formed recesses and holes, like for example a watch main plate. Work holding of an expensive and easily damaged component like that is often a challenge, especially when the holding method needs to provide for convenient and accurate centering on an already existing feature. A watchmaker's faceplate is uniquely suited to helping with that sort of issue, and I'll demonstrate exactly why that is at the end of this build series. Now, ideally of course, this sort of work will be done on a dedicated watchmaker's lathe, designed and constructed to be better suited to the task. But I've found this little lathe consistently delivers a high standard of accuracy, and I've found it to be an excellent platform for expansion with shop-made tooling. An example of what I mean is the screw head polishing tool attachment that I made some time ago. I based the design on the traditional hand-operated watchmaker's tool that's used to achieve the so-called black polish finish often found on the fasteners of a high-end watch movement. It mimics the action of the antique tool and works as a reasonable substitute for the genuine article, but at a tiny fraction of its cost. So I'm going to take that same practical approach with this build of a watchmaker's faceplate, and we'll see what we end up with. Okay, so ignoring the draw tube and centering shaft for the moment, the basic architecture of the tool is this: a true running plate with 3 toe clamps that hold the workpiece offset from the plate surface. There are 3 holes that permit inspection of the workpiece from the rear of the plate, and the clamps travel freely within slots for repositioning as required to securely hold the workpiece. Now, before we move on with the build, a quick word about the central arbor. Sherline sell blanks that fit their spindle taper either directly via the Morse taper or with an adapter sleeve that accepts a watchmaker's collet profile. Either could be made to work, but as it happens, I'm going for the adapter sleeve option. It makes including the centering feature a little more convenient, and it also gives me a chance to show a simple way that the machine can be tuned for even better performance. Every machine tool is built to specified tolerances, and this small amount of spindle runout is well inside what Sherline specify for their machine. For the vast majority of my turning needs, it has no consequence at all. But of course, adding the adapter sleeve that I showed a moment ago isn't likely to improve things. And this is a fairly typical runout for my machine with the collet adapter sleeve installed. It's still not a problem for most of my turning work, but for some of the more important tasks, it's a little more runout than I'd normally choose to accept. Fortunately, there's a really easy way to almost completely neutralise this error. A very light skim pass down the inside of the adapter sleeve shows what we're dealing with. Now, if that cut is taken all of the way to fresh metal, then the small error is eliminated, and we now have a true reference surface relative to the lathe. The small penalty is that to get the best out of this process, we have to locate the adapter sleeve in the same rotational position each time that we use it, which is easily done with the help of a small witness mark adjacent to a known feature on the spindle. If care is taken to properly align the sleeve each time that it's installed, the net effect on spindle runout is a dramatic and repeatable improvement. And I use this basic idea regularly across each of my machines. Whenever the accuracy of the outcome really matters, I'll generally find some way to make use of the lathe's natural ability to cut its own true spindle reference, and so create the best possible starting condition for whatever operation comes next. And certainly in this case, we have a reliable starting point for both making the tool and also its future use. Okay, so we'll come back to the arbor formation in a moment. For now, let's make a start on the main plate. It could be made from any number of metals, but I've decided to use aluminium bronze. It's reasonably hard for a copper alloy, which is helpful for a tool that'll likely take a few knocks through its life. And I really like the way that it cuts. The first step with this plate is to remove as much of the waste stock as possible, and also to leave behind some well-sized holes to use for later reference. Cutting slots is always a bit of a challenge for my little benchtop mill. It's just not rigid enough to resist the tendency to wobble under the cutting forces. But it's fairly straightforward to manage, by cutting the slot undersize, accepting the poor finish for the time being, and then gently widening out the slot to final dimension. Now these holes could be opened up all of the way with appropriately sized drills or end mills as available. But another option of course is to use a boring head. It's a really enjoyable way to get the hole not only on size, but also to leave behind a great surface finish for later reference. And finally, I need some visual guides to indicate where to start and end the curved slots when I come to mill them out later. Okay, so that's some of the features started. And we have what we need from that central bore to cut the main arbor profile and bring its boss to size, using the bore to confirm the fit. Now is a good time to put the final surface finish on the back and perimeter surfaces of the arbor. And the plate can then be returned to position and held with superglue for turning its outside diameter to size. And in this case, I found it's best to just let the glue wick itself into the join while holding the plate tightly in position. It generally means less time waiting for the glue to dissolve later, compared to being more generous with the glue on the inside surfaces. While the assembly is still glued together, the mounting holes and threads can all be formed at the same time, with the centre axis of the plate identified relative to the table, so the holes go where they should relative to the already existing features. Okay, so these two parts can now be separated after a soak in some acetone to break the superglue bond. Now we get to make use of those well-sized holes that I mentioned previously to locate the curved slots. I've turned up a simple plug gauge that's a close fit to both the reference hole and the rotary table subplate, and it also has a separate diameter that's a close fit on the holes. This will serve to bring the holes onto the axis of the rotary table. And of course, if there's any doubts about how well that's been achieved, a quick sweep can show where things need to move for correction. The point marks made earlier serve to identify the beginning and ends of the curved slots, and then they're opened up in much the same way as the straight slot. And with the part now looking thoroughly mustachioed and surprised, we can move on to styling the inside perimeter of those inspection holes. The commercially supplied faceplates tend to have a nice curved profile, which looks like a great opportunity for a custom form tool. It doesn't need to be anything too fancy, just a secure shank to hold a concave cutter, with the aim that it all be held in a standard lathe tool holder. For the cutter, this small slice of 01 tool steel will do the job. And for the shank, I have a length of mild steel from the scrap bin that's been patiently waiting for what looks like quite some time to be put to good use. Again, the superglue approach makes easy work of the location issues for holes and threads. And once that's sorted, the cutting face can be formed with an end mill, gently worked into the correct position to provide a suitable cutting profile. A standard red heat quench followed by a temper to medium straw, and the cutter needs only a final sharpen to be good to go. So to complete the tool, the end of the shank needs to be ground to shape for clearance within the hole, and then the cutter sharpened for final use. Okay, now how best to hold the main plate while making these cuts? Well, my go-to option for this sort of thing is generally these sacrificial aluminium faceplates. It's not strictly true for this particular use, but generally they're another instance of what I mentioned earlier, about turning reference surfaces in place to neutralise the small errors of these machines. Other than the main mounting boss at the back, I treat every aspect of this as a consumable item, to be turned or machined away as required, to give a true surface whenever I need it. For example, this central brass rod can be continually released, pushed forward, and then a reference boss turned as required. And over time, the plates tend to pick up all sorts of cuts and holes, depending on what they've been used for in the past. This one already has a couple of tapped holes from a previous job, and I can make use of at least one of them for this job. These other plates have all been sort of half consumed for whatever reason in the past, and can still be called into service by fitting to the main mounting boss if they should better suit the job at hand. And of course, it's easy enough to bring in a new plate if a problem can't be solved with one of the existing ones. Now in this case, I don't really need the consumable centre, so that can go. In fact, what I really want is a recess right here that I can use to give the cutting tool room to move as it forms the interior curves. And I need some additional tapped holes to accept the clamping hardware. Now speaking of clamping hardware, standard cap screws are fine, but I'd prefer to play it safe with the surface finish on the inside of those slots during the next operation. So I've taken the edge off the threads to minimise the chance of them doing any damage. And the same thing applies to the washers. I could probably get away with a commercial washer, but a larger set of soft brass washers removes any doubt about injuring the part from the clamping force. Again, that plug turned earlier gives a general location for the hole that's about to be shaped, and any small error in location can be taken out with the 4-jaw chuck. And as is often the case, the setup and preparation work takes up the majority of the time, while the cut itself is over in no time at all. The outside perimeter of the main plate also generally has a light curve to it, although this requires no special cutter. In fact, it's a good opportunity to break out the graver and have some fun shaping it by hand. It's also a good time to face the plate true to the axis of the lathe on which it will ultimately run. First by holding the part with superglue as before, and then by reversing the plate and using the fasteners made at the start of this video. Now I expect that the main plate is going to pick up a few bumps and scrapes over the rest of the build, as I test fit the toe clamps and so on. So I've left a little bit of extra material on both faces for a final facing cut at the end of the build, to leave the best possible finish for the final tool. For now, it's enough to give the plate a quick deburr in preparation for that test fitting. The fasteners, however, can be taken to their final blue state now, with heat applied over a bed of brass chips. And that's the first components complete for now. In the next episode, I'll make a start on the toe clamp assemblies. Thanks for watching. I'll see you later.